So like some washers. So we have y equals 8x cubed, y equals 0, x equals 1. That's all we have, right? So this is our region, bounded by those. So first I want to see that region, bounded by those. And then we have y equals 0. What is y equals 0? X-axis. And then we have what? X equals 1. Is that like x equals 1? X equals 1. And this is 8x cubed. So do you see that's the region? So we are going to rotate that thing around what? Around what? The line x equals what?
2.
2. So let me do like this. So we're going to rotate around that line x equals 2.
This washer or just a homework?
How do we know it's a washer or disc?
There's a gap.
There is space in between rotation and that, some empty space, so it's a washer.
Right.
So we need 2 radiuses instead of 1, right? So 1 radius is the, so do you see this region is bounded basically, if you go like that, this is bounded between left and right functions, right?
Mm-hmm.
If you go like around like vertical axis, like y-axis. This is like a y-axis, but it's not here, it's here, is that right?
Right.
X is like that, but yeah. So I'm gonna look kind of left and right functions. The closest distance is from here, right? This is one of the guys, like the right function, right?
Mm-hmm.
And this is the left function for that region. Do you see that?
Yes.
So from here to here is closer. So that will be that. If I call it small r.
Mm-hmm.
And from here to here, from this guy, is longer. So I call that one like a big r, right?
Mm-hmm.
From this function and that function. Questions there? The formula for the volume is integral, in this case, you don't look here, right? You just look at your region. From where to where? Where to where? No.
From
For
the axis?
integral limits, you look at your region.
Oh, yeah, yeah.
It's from 0 to 1.
The region.
And then, I think we do pi. I think we decided we can take the pi out. Or we can put inside. And then we did what? Big R square minus, move the y-axis, right? So I'll go what?
So then your
D.
limits is not from 0 to 1. Well, what is the top?
Yeah, this is wrong.
Oh, yeah.
This is wrong. This is wrong. First, dy is right? Those guys are x's. I want what?
So the
I want no x, I want what? Y. And this is an x, that's wrong. So I'm going to change to a what? So what are the numbers I want? I want this one and what? That one for the y-axis. So this one is 0, and that's a what? X is 1. If I put 1 here, I guess 8 times 1. Is that right?
Mm-hmm.
X is 1, right? That point, 8x cubed. 8 times 1, is that an 8?
Yeah.
If you plug in x is 1. Or solve them together. Do you see that? Is that at that point, x is 1, right? So this x is 1, but basically I need a y. How would I find a y? I plug in here, right? 8x cubed. 8 times 1 cubed. Does that make sense? So would that be, right? Is it okay with that?
Yeah,
So
because
should
it's
I,
y. Because y equals, right?
is that 8 then? What if this was the intersection of this? Let's say this is what?
Right.
Y equals x squared, this is y equals x cubed. Then you will have to what? Make them equal to each other.
Solve.
Right. Does that make sense?
Mm-hmm.
So to find the boundary, do we have another x on the side? You just simply go to the x and then go up to the y, and then
I'm
solve.
talking about this 8.
Yes.
Look at, if you look at a picture, this is what I want to find, right?
Mhm.
Do you know at that point x is what?
1.
1. How do you
Right.
find a y if you have the x?
Well, we already have the equation for that.
Yep, so that will plug in here, right?
Right, okay,
Does that make sense?
yes.
Okay, so if the axis of rotation is on the negative side, like.
Doesn't matter negative or positive. Right. It's just like vertical or horizontal. Like a y-axis or x-axis. Are we okay with that? Now we're going to continue. Now I have to figure out the small r and the big R. So let's, I don't know, let's start from the small r. In my picture, let me just interact. What is the small r? It's from here to here, right?
Right.
Can you figure out
2
small
minus
r?
1?
Was it?
2 minus 1?
Yeah, it's always the same, right? Doesn't matter from here to it's always 1, is it?
Yeah.
This distance is always 1.
Right.
It's 2 minus 1, it's 1. Also, I'll just put a 1 here. I wanted y, but number is okay, right? I want y, I don't want x. That's not x, so that's fine, right? How about the big R? Let me look at the big R. Well, big R is from where? From here to here, is that right? Is that right? Well, look here. If I fix, this is now different, right? Because if it's here, it's longer. So it's not 1, it's another number. 1, 2, 3 changes. Do you see that? Here it's even smaller, right? Has to go from this function to that, right? But so how do we go with that? If that's a fixed point, x, y, this is your x, this is your y, is it? Right? X is what? This way, y is this way. X is horizontal. But we go horizontal, right? This R is horizontal, is it? Right? So x is from, if it's a horizontal, it's about x. X is horizontal distance, y is vertical. Does that make sense? So, but you see, x is from what to what? From here to here is x, is it? Or not?
Yeah.
But from here to here is what?
It's 2 minus x.
I'm sorry, that's my r. That's my r, what I want to find, is it?
Big R.
Right, big R. Maybe I'll erase that. How about like here, like here? From here to here is x, is that right? And from here to here is my r, is it? I want to find that r, is that right? And from here to here is what? 2. Is it?
Yes.
So this is 2. This is the x. This is the r. You need the r, right? So r will be what?
2 minus x.
2 minus x, is it? Oh, x plus r is 2, is it? Yes?
Yes.
So r is what? 2 minus x? Are you okay with that? So we decided this is 2 minus x. So I will replace this by 1. I will replace this by 2 minus x, but that's a problem. Because do I want an x's here or do I want a y's? Y. So I have to change the x to a what? Y. But what's that about? It's about this guy, right? Is that right? It's about that guy, right? Is that right? Yes? The point was on this graph, right?
Yeah.
On this graph. So I'll solve that for x. So instead of x, I will put here y.
Right.
So this was what? Y equals x cubed. How would I solve it for x? 8x cubed. So how would I solve it for
Divide by
x?
8 and
Divide by 8 or 1/8,
cube
right?
root of 3.
So x cubed will be what? 1/8 y, right? Then we'll do what?
Cube root.
Cube root. So then the x will be what? It's 1 cube, 8 cube, it's 1 over 2, right? And then that's a cube root of y, is that right? Because cube root of 8 is 2.
That was to substitute for that one, right?
Yeah,
Big
to
R?
solve this x in terms of y, so I can replace the x, because I don't want x, I want y. So that will be 2 minus 1/2 cube root. That's in your final. Should follow this. Questions there? Now we change it. No x anymore. So now we're going to play. Yes?
how you choose a point there for the big R? How you choose?
Big R, it's from here. So any point there. Doesn't matter, any point there.
So I can go to the bottom and just.
You can go here, you can go here. Yeah, it doesn't matter where you are. On this graph, this is always X, right? This is your R. And this is 2. So R is going to be 2 minus X.
Can I go to 0?
No.
0, 0?
No,
No.
no. Yeah. It has to be on this graph.
So wasn't there a rule where it said right, left?
Yeah, this is the right left we're kind of doing. Right?
Mhm.
I was doing subtract right left. No, you're talking about area. Area always was what? Area always was right minus left, right?
Right.
But for this guy, it depends where is located your what?
Axis.
This line could be here, could be here.
Yeah.
So the small r is always the closest one.
Okay.
The bigger one is the largest distance, farthest. That's your x. At some number, which is happens to be ln of 9. But that is negative. How would I change to positive?
1 over e.
Positive ln of 9. But what is e to the ln of something?
9.
It's just a 9. So this is 1 over 9. No, your example was different thing, not the specific thing. But for this problem, are you okay with that? I want to continue. So now we got that point. Oh, we need one more point. What is the point on the top? How would I figure out this point on the top? I still need that. Who can help me
Plug
with that?
in x equals 0.
That's y-intercept. So it's x equals 0.
Right.
But on this guy, is it?
Mhm.
X equals 0 for the intercept
It's
for
1.
that, right?
Is it 1?
X equals 0. So it's x equals 0. You get y equals 0, which is 1. So that's the 1. Is that right?
Mhm.
Now we have to do 2 integrals. Oh, this one we decided we can do without integral. But what would be this with integral? This box, the rectangle.
From 0 to
It's
2?
integral.
0 to 2? 0 to ln.
Isn't it right minus left?
Yeah.
Right minus left. But what is the right there?
2? Oh, ln of 9.
First of all, is it dx or dy?
It's a
It's
y.
dy.
You see, because we go like to
You're-
the y-axis.
Yeah, you're integrating vertically.
Right. So and this is x equals what? Ln of 9
Yeah.
minus y equals 0, right? X equals 0. This is what? X equals ln of 9. This is what? X equals 0.
Right.
So I'll do ln of 9 minus 0.
From 0 to 1, 9.
From 0 to 1, 9. Is that right? I'm just doing what? I'm just doing this one. Only this one. You see that? Because I have to do 2 of them and then add. But that's just ln of 9 is a number.
Check it out.
So what would be the antiderivative of this number?
X.
There's no x and y, so it's a number. So it's going to be ln of 9 times what?
X.
Well, x is a y, right?
Oh, wait, wait.
Both from 0 to 1, 9, right?
Right.
This is a number. No x, no y.
The answer is 0.
So it's going to be ln of 9 times 1 over 9 minus 0, right?
Right.
0 times. This is times. Is that right? This is times. Is that right? Well, this is then ln of 9 over 9. So what if you do as a geometry? How would you got width times length, right?
Yeah.
What is the width?
Is ln of 9?
Or what is the length? This is ln of 9, right?
Yeah.
And what is the height?
1, 9.
1, 9. Is
over
that the
9.
same thing?
Yeah.
Because it's a rectangle, right? Because that's a rectangle,
Fine.
right? But now the other one is not a rectangle. So the other one is, that was nice. The other one is what? Same formula, right?
Yeah.
What was the other one? It's still right minus left,
Right.
but now we go from what to what?
Top to the
y-
bottom or bottom to
1?
top?
Yeah, still we are doing left and right.
1, 9.
Oh,
We'll just
yeah,
take two
yeah.
portions because here the right function is different. Here's a different right, here's a different right.
Yes.
Do you see that?
Right.
It's not the same right function.
Yeah.
So now this one goes from 1, 9 to what?
To 1.
1, right?
Mhm.
Right? So from 1, 9 to y goes from 1, 9 to 1. And what is the right function here?
E to the negative
e to the negative x minus
0, 0.
0. But what is my problem? We don't want an x, right? We want a what?
Y. So to change
So I
the
have to
terms-
change this. So for x.
And then
So that was what? Y equals e to the negative x. I have to solve for. This is not like your exam, but we are just thinking. So we solve it for what? For x. First, I don't want this negative. Oh, you can have the negative. You can take ln. Oh, let's do the ln.
1 over e
So
to the
yeah,
x.
you can. It's your choice. Do you want me to keep the negative? I do it. If you don't want to keep, yeah.
Why is the limit from 1 over 9 to 1?
Because you see, did you get this point? Is 1 over 9?
Yes,
Now you see, I'm doing purple integral on the red.
yes,
So for the red one, it starts from 1 over 9, right?
yes.
All the way to 1.
I thought it was from this way to this way.
No, we are doing dy. We are doing left-right. Left-right means use the y-axis.
Oh.
Just left and right. Like,
Oh. But, yeah, that's what I'm saying. Why is it from 0 to that point, or to e
That would be
over
dx.
negative x? Isn't it 0 from? Oh, yeah, that's what.
no, we did two. We already did this one, this eta. This was from 0 to 1, 9. Now we forgot this. We're just doing that part, this red part. It starts at 1, 9 to the 1, right? This was from 0 to here. This goes from here to there.
What I was switching was the limits to the actual, I was switching them around.
Right?
Yeah, so.
Right. Well, okay, let's keep the negative. So I'll take ln on both sides, right? If I take ln, I take ln. That's going to be ln of y equals negative x. Is that right? Is that right? Is that right? So x will be what? Negative ln of y, is it? No?
Yes.
I just took ln.
Yes.
Negative x came down, ln of a is 1. That makes sense? Okay. So then I will have to change this by what? Negative. Of course, this was not in your exam because we do not know how to do this kind of integral. Because we do not know ln of y is what? Antiderivative of what? We do not what? We do not know. So I'm going to leave it like that. But this is the process what we should have done. This should have been something that we can what? We can do, we practice to do or something like that. Are you okay with that?
Is it a lot to do that?
Well, we just don't know how to do it, unfortunately.
Okay.
But this, what you should have, this was not in your exam. That was different, but.
This wouldn't be as same as taking the antiderivative of x.
No, well, we have to have something whose derivative is that, is this, but we don't know whose derivative is that.
So x ln of x minus x.
Say again?
So y ln of y minus y, right?
Y?
The antiderivative.
What are you saying? What?
Is it 1 over y? No, I don't know.
Y ln of y minus y.
Y ln of y,
Minus y.
but just this gun.
Minus
Yeah.
0, it doesn't matter.
So y ln of y?
ln of y minus y, is that's the antiderivative.
Minus y?
Right.
Well, why would you? Okay, what is the derivative of that?
That's the question.
We want derivative of this to be that, right? But that derivative of that is not that.
Right.
This is hard to do. This is hard to do product rule. Is that what you're saying?
Right.
So let's not discuss that. We at this moment don't know. But if I ask this kind of question, what do I say? I will say what? Write the set up and do not evaluate. Then you should be able to write what? The set up. Then I will say don't do antiderivative, just what? Don't evaluate, don't calculate. But set up, just give me the integral. This you should be able to do. After this, we unfortunately cannot. We have altitude of 3 miles. We have a plane. Speed of the plane is also given 440 miles per hour. And it passes directly over a station. Find the rate at which distance from the plane to the station is increasing. When, you know, for all these problems we have when at some instant. When it is, meaning the plane is 4 miles away from the station. Right. So let's see. After those two word problems, I wanted to remind the things you did bad. We should do one implicit differentiation, one logarithmic differentiation. I think those were not too good. And I will continue. Right. So okay. So what do we have? So we have a station. Like this is the ground. We have a station here.
This is the review question?
Yeah. So we have a plane that is what? Going like constantly the same altitude, same height, which is 3 miles. So my plane. So what is, we want to find the rate at which what? Distance from plane to station. What is the changing? What is the distance from plane to station? As this, when it's directly there, right? But this is going to continue what? Going, the station is not. So this distance will change, right? It will increase. So see that? If you are here, distance is even what? Greater. So it's increasing. But if you, yeah, okay. So what if we call this distance traveled of the plane x, and distance between the plane and station, which is this, because it's changing, whatever you want, y, z, I don't know, y, he says. This y is kind of the hypotenuse, do you see that? It's changing, is that right? In here, this y is 3, but it's just there, and then it's become more and more, right? This is changing. This is the hypotenuse. This is always 3, right? X is the distance of the plane on that horizontal line, because it just goes the same altitude, same height. Height is not changing. So we know we have what? Or we are given what? Some numbers. 440. What is 440?
It's the rate.
Speed of that plane, so is that dx dt? Why is it dx dt? If the distance of plane is x, the speed is the derivative of that. Is the derivative of your position. If the position of the plane is x, the distance is x on a line, derivative of that is your speed. Does that make sense? Absolute value of the derivative is the speed. Derivative will be the velocity. Absolute value of that will be the speed. No? The derivative of the position or your distance is your velocity. Absolute value of that is your speed.
Mm-hmm. So that's
The rate of change of x with respect to t is the velocity. Speed, absolute value. So can we go with that? Okay. So we want to need to find what?
What's the distance after 4 miles?
So no, we want to find what? Rate of change of the what variable?
x
Y.
or yeah
The
y.
x we know is change. X, this is the rate of change of x because that's the speed of the plane.
Right.
But the y is the one that is distance from a station to your plane, and that one is also changing. We want to find dy dt. That's the rate of change of the y, which means it's the rate of change of the distance from the plane to the station. Right?
Yeah.
We want to find the what? Rate of change of the distance from the plane to the what? Station, and that's the y. And the rate of change of y means dy dt. Rate of change of x is dx dt. Does that make sense?
Yes.
Does this rings a bell?
Mm-hmm.
But when? At a specific point. At what instance? What second?
After
When
4 miles?
it's 4 miles away from the station, so what is that for? Y. Because the distance from the, so this y is changing. It was 3, becomes more and more and more. At the instance when this becomes 4, we want to know how fast this is changing. So usually we relate those x and y with an equation. What equation will relate x and y?
3 squared plus x squared equals y squared.
So right.
Pythagorean.
Right. Fortunately, the 3 is always 3 there. So what is the next step after writing the equation?
Plug in X.
No, never do that.
Okay.
No. Take the derivative. Take the derivative with respect to what variable? The t, right? The only variable is the t, right?
Yeah.
X and y are not what? Are not variables. Those are like functions of t. They depend on t. And then with the implicit differentiation, so what do we get on the left side? So what do we get on the left side? 2y dy dt, you said?
Yeah.
Equals what?
2x dx dt.
And then what else? That's it, right? That's 0. So we already have what? This guy, right? This we need to find. And how about x and a y? We have the y, so what we are missing is the what? X. But when this y is 4, can we figure out the x? Y is 4, this is 3, so we need the x, right, at this moment. We'll just use that, right? So that's gonna be what? 9 plus x squared equals 16. Yes. So 9 plus x squared equals 16. X squared equals 16 minus 9, which is probably what? 7. X is plus or minus 7, but it's distance, so it's radical 7. There you go. So 2 times y is 4. dy dt we need to find. X we figured out radical 7. Dx dt is 440. So this is an 8, right? So we'll divide by what? We divide by what? 8, and we may cancel something. Does that make sense? Or not? I guess you can make this 4, and you can cancel that as 110 maybe. Questions then? Typical problem for your file.
Oh, great.
Distance, I'll give you distances maybe, something like that. I divided by 8 to get the dy dt because 2 times 4 was 8.
So it's 110 rats, right?
I think so. If I cancel. If I'm not wrong. Questions?
So basically, you took the derivative of the y, right?
Of
For the
both sides.
Both sides. And then you
But
made
the-
it. Why'd you make it 2y? Oh, because that's what you got. That's the
It's
derivative.
2y, but if the y was like an independent variable. But independent variable is t. Y is a function of t. It's an
So why
implicit
change?
differentiation. You have to
So this is
divide it.
implicit.
What do you think?
Nice.
Make it look easy.
Right.
Because of the distance is always going to be, or the speed is always going to be positive. You don't
Yeah,
get
that's
negative.
positive because it's increasing, right? The y is increasing. That's why dy dt, the rate of change of y is positive.
Where did the 8 come
2 times 4 was 8, so I divided by it to get dy dt.
from? Oh, I see.
Right. So I wanted to get dy dt by itself, so I divided by 8. So 2 times 4 cancels. I wanted to get dy dt, right?
Because you want that new point.
I want dy dt.
Yes.
That's the question, find dy dt. So I solved for dy dt. So I divided by 2 times 4.
I see.
What's the hardest part about this? It's so simple right now.
The hardest part of this problem is being able to do
Knowing when to solve, knowing when to like
What's up? To
When you're like, I always
I mean,
get,
they should all be
like, I
repetitive.
just wanna solve it, and then I like miss equations, when I'm like, oh, but where do I plug this stuff into?
right.
And I
Let me
don't
see
have
the
any
picture
equations.
first, right? Go ahead. You want to continue?
No, I was gonna say, because they should all be repetitive, just different distances.
They all should be what?
Repetitive,
Repetitive,
Yeah.
meaning, you mean the problem similar, that's what I mean?
like problem solving, same steps, because it's still, the plane is still moving.
Yeah, so the step is, you wanna see what's going on in a picture maybe? It's this kind of distance question, always we have some right triangle, and then you wanna call x and a y. You wanna know what you are given, what you need to find.
So you
And
may
then
be
you
given-
come up with an equation. And then you have to take the derivative implicitly. And then you have to plug in the things you have.
It's miles per hour, right?
Mhm.
Can you do that, there was that, I don't remember what the formula is called, with that big C, over the little c equals that big A over the little b. What's that one? And then the
Oh, that's
big B?
first.
Couldn't you do that one to get that top corner? Does that make sense? Because you already have the y, which is 4, and you have 90 degrees. So all you have to do is solve for the 3.
Oh, no, you don't have the y. If you're saying, if you just plug in here 4 and find the x, that's not gonna do the job. Is that what you're saying? No. This y you don't have. It's changing. Here is something, here is more. It's more.
It's changing.
But isn't it a fixed distance because when it is 4 miles away?
At that moment it's 4.
At that moment.
Right.
So that's what we're trying to find at that.
Right. So don't ever plug in the things at the beginning. Only after the derivative, you get your rate of change, dx dt, dy dt, then you plug in things. Just so much to cover. So what we are gonna do after 10 minutes break, we are gonna do another problem. And the y was, we already had a formula for y.
Yeah.
What was the-
62 down.
62
Over x squared.
over x squared. This was how many zeros here?
Yeah, two zeros.
2 zeros.
Yeah. Over x squared.
So I squared that.
25.
20. So what are the dimensions?
25 centimeters.
50, 50, 25. X, X, Y, right?
Well, at knowing 50 equals x, you could have just plugged that in.
Right? 50 equals X, you could plug in
And then get
the Y.
the last
Right,
one.
I plug in here.
Mm,
You could have plugged into the value.
right.
How you feel about, yeah.
I have a question.
Mhm.
What's happened? And you have the SQ. No,
Mhm.
the line, no, yes.
I just did common denominator, X.
Local minimum.
You okay with this? So these are two kind of words problems you will have in your exam. Let's do an implicit differentiation problem. At the point 0 and 1/3. Now why did I think a little before writing this point? What do you think? Because this point should work for that.
Right.
But if I put x is 0, that's gone, right? And y becomes what? 1/3. It should work.
Right.
Anyway, so how will we do that kind of problem? What do you need for equation of a tangent line?
So,
Slope and a point. We have a point, we are missing the slope. How do you get the slope?
With 2 points?
I don't have 2 points, I have 1 point.
derivative.
Derivative. Slope is the what? Slope of the tangent line is the derivative
Right.
at that point. You've done that kind of problems. So we need a derivative. But unfortunately, it's not solved for y, is it?
No.
So what kind of derivative I have to do? Implicit.
Look at that.
Right. So because it's not solved for what? For y.
Yes.
So I'm gonna do the derivative with respect to x here, and with respect to x here.
Hmm.
So on the left side, what do we get? What rule should I use? Product. So I have to do derivative of x times no derivative plus what? No derivative times what? Derivative. That's the product rule, is it? Plus what? That's for this, right? And then what do I do here? Plus 3 times what? You can write dy dx or y prime, whatever you want. What do you want me to write? Y prime, dy dx, whatever you want.
Times y, right?
Equals. No. Because there's no change rule, it's just a y. If it was y squared, y cubed, you have to do change rule. If it's a y, you just do y prime or dy dx. Right. If it's just y by itself, it's just y prime.
Yeah.
Okay. Okay. He doesn't believe what I'm saying. He doesn't. Is my instructor right? Okay. What about what is it on the other side? Derivative of x is what? 1. And the derivative of 1 is, I guess, 0. Now here, well, what is the derivative of x? 1. So it's just that, right? But now, what is the derivative of that? 2y prime. Or you can write dy dx. Questions? And the next step will be solving for y prime. Well, this one, if it's a tangent line, you don't have to solve. You can plug in the numbers, x and y, and let's solve. 0 and 1/3. But let's solve. Let's solve. So how do I solve? I'll move this y squared to where? To the other side, right? That will give me 1 minus y squared. Is that right?
Yes.
And to save time, because we don't have much time, we're going to do more problems. And then, so I move this. And then what do I do here? Factor y prime. I'm going to do it at the same time. So that's going to be y prime times what? 2xy plus 3. Did you get what I did? 2 steps, right? And then finally I will divide, right? By what? So my y prime will be what? This is, we did implicit what? Differentiation. And finally, how do I get the slope? I plug in what? The numbers, 0 and 1/3, right, for x and y. Is that right? The way I took the numbers, we have to probably do a little algebra. But let's do it. So then that gives you 1 minus what?
8 9 7 3.
But let me try it. 1 minus square, right? 1/9, is that right? Over what? That's a 0, that's a 3. You can write 8 9, so you can multiply by 9, right? So I don't like that, so I'm going to do that. How about like times 9 times 9? Or you can do 8 9s. But that's going to be 9 minus 1, is that right? Or not? Does that make sense? That's my what? Derivative, but that's also what? Slope. So we got the slope. This is the slope. So how would I write the equation? Y minus what? 1/3 equals
to 8 over 27 times x minus 2. It's just
questions.
yeah, it's so
So after you get the y prime You
Then I
plug
plug
in.
this number. This means like plug in these numbers.
Right. You
It's
plug in.
slow. The x is
You
0
plug in 0 for x.
and 1/3 for y.
Oh, okay, yeah. Plug in both.
Right. Somebody said, do you? Who said so? Yes. Next question.
Is there any linearization?
Let's do logarithmic differentiation and then we'll do linear approximation. Right, we'll do both. We now do logarithmic differentiation. That's also, the problems we do today, it's in your exam, right? You're fine. So logarithmic differentiation. Do you want me to do from here or you want me to create one? Because you were looking at me.
Yeah.
You want to do that one?
Yeah, you
Okay.
can do one.
Yes.
It's radical x minus 3 over x to the 8
Hold
plus
on.
1.
X minus 3
Mhm.
over
X to the 8 plus 1. The whole thing's under a radical.
like that.
Yeah.
And is it equals to what?
It's just y. It just is y.
Hmm?
It just, yeah, it's just y equals that.
Okay. Let's do that. So how do you do, what is the first step for logarithmic differentiation?
Is that in the review?
Yeah.
This is number what?
22.
22 and it says to logarithmic, right?
Yeah.
Practice. So how do you start? How do you start logarithmic differentiation? Take ln on both sides. That's the first, yes.
We're changing the problem because the one that's under has everything, no two radicals.
Oh, no, hold on. So what is it?
It's just one big radical.
Oh, like that?
Yeah.
Oh, I'm sorry. Sorry. No, I'm not. I just misunderstood it. Right. So, how come you didn't say it correctly before?
I thought you understood, but you just kind of left it there.
No, Right. Okay, so first step of logarithmic differentiation, take ln on both sides. So I'm going to take ln. And then do I take the derivative? No.
Use rules.
The second step of logarithmic differentiation is apply all the possible rules for logs to simplify the right side. So first, I'm going to save your time because we don't have much. In order to apply the rule, I have to change that to what?
1/2.
1/2 power.
And then you move
So
it
because
to-
logarithmic rules changes the power, right? So how would I change that?
You move it to the.
Goes outside 1/2. That's how I can use the rule for logarithms. So this will become, let me just skip this for now. ln, so 1/2 times ln, right? And then you have to think, can I apply?
You can subtract it.
Yes, you can apply more rules. You can simplify more. Log of the top minus log of the what? The bottom. But what if you did, some of you did wrong? This 1/2 is for this whole thing. So it's gonna be ln of what? X minus 3 minus,
X, let's say. ln, let's say.
can I write this as ln of x minus ln of 3? No.
Yeah.
No. There's no rule like that. I'm done. No more rules of log I can apply. Cannot simplify the logarithm anymore. That's it. Once you cannot simplify the logarithm anymore, then you do what?
Derivative.
Derivative implicitly on both sides. So what I'm gonna do, sorry, it's a little below, but I'm not gonna rewrite it because of time. So what I'm gonna do here, what? Derivative with x, and then here what? Derivative with what? X. By the way, I think it will be much easier to do before that one more step. Distribute this 1/2. Now you don't have to, you can keep it there, but you could distribute this 1/2 where? Here and there. You should write as next step. I'm gonna do just like here. So just because of time, I'm gonna just write here what? 1/2, 1/2, that's your next step. And then now I'll do the derivative. Because I'm gonna do derivative here and here, I don't wanna multiply at the end by 1/2. I did it now. So 1/2 will
Right.
stay there. So now we do derivative.
Okay.
So all again on the right side. Left side, left side. It's 1 over y, right?
Yeah.
Times y prime. Chain rule.
Okay.
1/2 is there. What is the derivative of that?
It's 1 over x minus 3 times 1.
Derivative of inside, right? Which we'll do soon, right?
Yeah, just 1.
The one. And how about this other one?
1/2 of the
1 over, 1/2 of 1 over
over 8 plus 1 times
Chain
the
rule.
derivative inside.
questions. Well, that will become just a 1. Yeah, go ahead.
Cool.
So that will become just a 1. That's a 1. And this is a what? That's a what?
8x to the 7.
8x to the 7, right? Plus 0. Finally, I'll multiply both sides by what? What am I finding?
Oh.
Find what? Derivative y prime, so I multiply by what? How do I get y prime? Times y,
times
right?
4, yeah.
Times y, this is y, right?
Yeah, times y.
On both sides, right?
So everything times y.
So basically what is going to happen, y is going to go the other side, but I'm going to replace the y by what?
By the original.
By its original function. So I get y prime equals y, but instead of y, I copy from where? From there. It was like a square root, if you wish, I guess, right? And the rest. If you let me, I can do a little algebra here. If you don't, I won't.
Go.
I'll just multiply those, right? That's what? If you multiply, that's what?
1 over
2x
2x
minus
minus
6.
6.
And then I'll just put this on the top, right? And then just multiply the denominator, so it's what? Yeah, is that what I get?
Mm-hmm.
And this was my what? This whole thing was divided for the y, right? This was the y, original y, which I replaced. You should be able to do this. Yeah. Questions? Okay. Linear approximation. Before doing linear approximation, I will ask you what? Use a quotient rule, do a derivative. Use a product rule, do a derivative. Use a chain rule, do a derivative. Problems we did today, I will ask them to you. I will also ask you what? Graph. Remember in one of the exams we graphed? Minimum, maximum, concave up, down, inflection point, graph. I'll ask you that. Right, so those are the kind of questions, right? I asked you the chapter 6 questions, like we did today, right? Chapter 5, substitution. I will not ask you those sigma limit n goes to infinity. Remember the sigma?
Yeah.
Yeah.
Just want to know that?
No. You said no. You just said no.
No, but I never said I don't change my mind, right? I change my mind every 5 seconds.
You already did the test.
Make it work 12
Okay, let's continue. Yes?
That's the only one I know
No,
that's
well, maybe like 15, 17. Maximum 20, less than 20. Less than 20. Okay, I want to continue linear approximation. one? E square root, cube root, sine, cosine,
The one on the test.
and some of those. How would I decide what number to put there? It should be close to something whose square root I know. Like I know square root
16,
of 25, of 9,
25, 16,
16, so
9.
close to those. How about I know square root of 16, right? So what if I write 17.1?
Okay.
You have to come up with a function at a point, What function we will use? If it's square root, you go with square root of x. Or should I call it f of x? And then what point? The point will be nice point whose square root you can do. 16.
So, you can come from either left or right, right?
Yeah, just as long as it's close to 70.1, but the closest point to 70.1, that is whose square root you can do nicely. Okay, so to do that, to do the linear approximation, it's the same as the equation of the tangent line. Now, I don't know if you want me to write it as a formula, or you want to remember as an equation of a tangent line. I can do both if you want. Or I can do, so basically it's an equation of the tangent line. But also there is a formula for that. As a tangent line is we just did. You need the what? Derivative, and then what? And a point. But we already have x. Can we find a y coordinate?
If we plug in the x, we find
Right
y.
there, right? Square root of what? 16, it will be what?
4.
4. Then you do equation of a tangent line. How do you tangent line? You need your what? Derivative, right? So you need your y prime. But if you think of this as x to the 1/2 to do the derivative, what will be the derivative y prime? 1/2 square root of x. Because 1/2 minus 1 is negative 1/2, I think, right? Power rule.
Oh, okay.
So, but you need the derivative at a point. Actually, yeah. So what happens? We need a slope, basically, for tangent line, the slope. Like we just did, right? So we'll plug in our point, right? X is 16, y is 4, but we need only x here, right?
Mm-hmm.
Is that right? Well, when I do this, I don't know if I use this notation. Have I used this notation? Oh, sorry. Sorry,
Okay.
you'll use it in some class. So I have to find y prime at the point what? X is 16. So what is that? 1 over 2 radical 16. So 1 over 2 times 4. So 1 over 8. And how do you tangent line? We do what? Y minus y1 equals m times what? 12, right?
Right.
So what do I do? Y minus what?
Before you go any further, that's
Please.
the derivative of that
Right.
equation, right?
Of this.
Right.
So what is the point? The point is what? X is 16, y is 4. X, y. X was given, y I figured out. So how do y minus what? 4 equals m is what?
So
1/8 x minus what?
16.
16. Now once you solve this for y, that's the linear approximation. Why you solve this tangent equation of tangent line? But I can distribute the 1/8, right? That's what? 1/8 x minus 2, is that right? And then I add the 4, so my equation of tangent line will be what? Plus 2? This is also linear, this tangent line is also what? It's also called what? Linear what?
Approximation.
Approximation. Now you can remember this as a formula, or you can just find the equation of tangent line. Are you? Okay? Sorry, ask something.
What was the formula?
Formula was this. Y equals f prime, which is that, at x, at a, times x minus what? X, should I call A?
Yeah.
Just like this is x, the point. And then plus f of A. You can use this formula. You could have used this formula. And the A was your point, which was 16. You could have done that. But you could also do just equation of a tangent line. It's the same thing.
Which one has?
Either one gives you the same result.
Which one you could do less mistakes on?
Less what?
Which one has less likely to do mistakes, less steps?
Either one, you're likely to do mistakes if you're not careful, right?
So we would plug in 17.1 to the x right there?
So we're not done. Let's continue, right?
Yeah.
We got this. Then all you need to do, plug in your 17.1 in here. So so you're gonna have this is approximately equals 1/8 times 17.1 plus 2. And whatever you get, that is your what? That is your what? Linear approximation. Does that make sense? I will not do that, but that's your answer. Just replace the x by what? By this x.
So after we get the y, 1/8 x plus 2, what do we do with that?
We just replace the x here by this x.
The approximated.
Oh, I'm sorry. By 17.1.
Alright.
Like that. Because what happens? Look here, this thing. Do you know what this is? This 1/8x plus 2 approximately square root of x. This is an approximation of square root of x. Square root of x is the same as that, but that's not true. These are equal to each other only when what? X is close to 16. If x is close to 16, instead of doing square root, you can do linear thing. You can just multiply and add. This is the approximation for what? For this. I don't think you feel comfortable with this, right?
No.
You forgot those things. Right?
Yes.
It's kind of work, right? You forgot those things.
I have a question.
Yes.
How did you get that y prime numbers?
Yeah, I did the derivative of this. 1/2. 1/2 minus 1 is negative 1/2, and it goes down there. I want to stop here and make the, yes, we're going to stop here and make some announcements.
Yay.
Your practice exam and also your chapter exams, tests. Study each problem you have, including washer, which was not included in your last exam, including this, including areas, right? Integral with substitution. And again, I most likely will not do those sigmas. And then what else? The word problems we did, chain rule we did, quotient rule we did, product rule, right? Implicit differentiation, logarithmic differentiation.
The segment was the sum, so we don't do the n equals 1.
Yeah, we will not do that.
So x, y, or x.
We will not do that. We may have box that we could practice. So you will have a what? Minimum maximum word problem and the rate of change, dx, dt, dy, dt word problem. Any questions for me? General questions? Wait, we're not done. Yes. Oh yeah. Thanks. So in the syllabus, I said that you're gonna get 7% for quizzes. During the semester, since I was extremely slow, I didn't have time to give you quizzes in class. So what is going to happen to that 7%? Your grade just will be 7% less. So if you have like a 87, 86%, I subtract 7 and I gave you 79%.
That sounds good.
No. This should be up.
He's live right now on Facebook, live.
I want to check. How do you know it's up?
Yes, look.
Hey,
That's recording?
Right.
Okay.
So what is gonna happen? Actually, it should have been up before. Now you can. Okay, that's okay.
So A is 85.
So what is gonna happen to that 7%? It's half of that 3.5% will be added to your exams grades because homework cannot be more than 10%. Then the other 3.5% will be added to your what? Final. Okay. Does that make sense? What I just said. So your percentage for the final and the what? Exams will go up by 3.5%.
Exam?
We are not done yet. I want to answer the question. Yes. Go ahead. So let's pretend, I don't remember the point. Let's pretend your midterm exams were 50%. I don't really know. Let's say I said your midterm exams were 50% and I'm dropping the lowest score. Right? So I drop the lowest score, instead of 50%, then now will worth 53.5%. So 3.5%. Does that make sense?
No.
It depends. In general, let me say, if in general, since the quizzes, hold on, I want to say, since the quizzes, you don't know what is in the quiz. A lot of times students don't do well on the quiz, right? That's what happens, I think, from my experience. So maybe it's better to add. It depends. What would be your quiz grade, right? A lot of times quiz grades are not that good during the semester. So it's now, it depends. Yeah, I can't say, but it's not too much difference. It's 3.5% difference, but that's what it's gonna happen. Your face says what he's saying. Yeah. So, and I want you to still have time to ask your questions before your final.
Can you just put the points like less, just take away the points of the quizzes and leave the overall, instead of being 400,
No.
take 150,
No.
for example.
But then again, like, aren't the, you said that 2 quizzes are dropped too?
Yeah, no, we don't
There's
have
no
quiz.
quizzes.
Well, but
Test.
you're gonna have a lot of quizzes, right? So. I will drop some of the homework grades, lowest homework grades. I'm gonna download your homework as an Excel. I'll drop, let's say, maybe like 3 homeworks, right? Lowest ones. I'll drop those.
How about 7?
I don't remember how many homeworks are there. Yeah.
And for the people who has 100%.
Every single one has.
Yes.
So the final is June 4th.
I have 100.
Sorry.
So final, June 4th, 8 o'clock.
Yeah, so hold on. The
June
final
4th.
is June 4th. Not next week, but the week after that, Monday at 8 p.m., different time, right? Here.
We have 2 hours?
You have 2 hours for the final, 8 to 10.
So,
20 questions.
Huh? It will be less than 20.
Okay.
Less than 20. Maybe 15. 5 questions.
PM. PM.
Do 20 easy ones.
Hold on. I didn't hear what you said. June 4th. That's in your syllabus. That's the last day of the finals.
Yeah, June
Anything
4th,
else you want to ask?
Monday.
What about us? Had 100%.
Well, then you have it, right? Is this something like, what if you got everything 100%? Then you got 100%. So, right? Dropping always was like that. Like even if I drop the exam, so some people have.
You forgot to take out the review for chapter 5 on the homework.
For the grade. Yeah, I will. So chapter review assignments, I will not count as a grade because I announced that. But you should work on your practice final, right? You should work. So this practice final will not count towards your grade. When I take your all the homework, I will not count those. But you should work on that. So I'm gonna resend. I just sent you, but I'm gonna do another one because for some reason some problems were not in there, right? Okay, anything else?
do you have washer review college?
Yes. Done. That's it. See you next time. And again, if you are planning to fail the class, I offer the same class in fall.
Preference is high.